Hi guys, welcome to Mr. Hescock's Life Science Chapter 6. So we're into evolution. Evolution, when you think about it, you really only need to think about adaptations of organisms. So we'll talk a little bit about history of life on Earth today, how has life on Earth changed, and you'll end up reading 169 to 175. So the origins of life on Earth. So life first started 3.8 billion years ago. Fossils have been found. We radioactive dated them. Um, and these fossils tell us a lot about what's going on Earth. So if you don't know anything about how Earth may have formed, so the Earth formed from rocks and debris colliding with each other, getting pushed together, and eventually you get pressure, and that forms a planet that's really molten at first. And as it molten cools, this is the Earth, as far as we know, is about 4.6 billion years old. So you're talking about 800 million years of no life on Earth. We do believe the first water on Earth came from volcanoes, although the Earth atmosphere would have been very poisonous, full of methane, full of ammonia, carbon dioxide, lots of nasty stuff. But over years and years and years, if you have enough steam into the environment from the volcanoes, you can get rain. Rain equals water. Water cools off the Earth, and oceans form. We do believe that the first life evolved in the oceans. There are three types of fossils. Sedimentary rock, which are rock formed from sediments, which is dropped usually by water. So it could be sand, mud, things like that dropped, or in some cases the sediment can be carried by wind, but water is much more efficient. Most of the fossils you've ever seen are all sedimentary rock. Now, amber fossils are from hardened tree sap. They can be leaves, insects, spiders, or even I've seen small um, geckos preserved in amber that got stuck and then it hardens. And then some of the more interesting ones, such as like mammoths and ancient cavemen frozen in ice that have fallen into ponds or areas where they just became frozen for thousands of years. There's an amber fossil. There's an ice fossil with a mammoth they found. Now, when we're aging fossils, there's something called relative age. So relative age, you look at the layers of rock. This gentleman here is pointing to different layers of rock. As sediment is layered, the oldest layers are on the bottom. The deeper in the layer of rock you are, the older the fossil. Now, it doesn't tell you the exact age, but it can tell you one fossil being older than another. And now we call that the law of superposition. Now we have absolute age. Absolute age is like radioactive dating. Radioactive elements decay at a very steady rate. So much so that we can calculate how old a rock is based on the radioactive elements that are in it and what those elements decay into. Once you know the amount of elements in there, we can calculate something called a half-life, which is the age that it takes for half of that to decay, and you can get how old the object is. Once we put all of these fossil information with the age, the Smithsonian Institute has a really nice fossil record of all of the life that they have found on Earth. So basically, you start piling up when organisms were on Earth and how long ago they were here, including when they appear and when they disappear, because most of the life on Earth has gone extinct. Everything changes. So this fossil record is like this complete record of all of the life that's ever been on Earth so far up to date. But that fossil record also gives us scientists an example of how organisms have changed over time. We know that we start out as simple one-celled organisms that were living in the ocean, probably feeding on material. And then you have all of this other stuff going on where they got more complex to becoming photosynthetic. Photosynthetic organisms become and change the atmosphere. Once you have photosynthesis, you end up with multiple different types of more multicellular organisms. So the first organisms were unicellular heterotrophs, meaning they had to feed on something. Hetero means different, troph means to feed. So they probably fed on the stuff in the ocean, Eventually, autotrophs are self-feeders. Those are your plant-like uh, photosynthetic bacteria, and they changed the Earth. They were the game changers. Once we had oxygen on Earth, life exploded because you need oxygen for cellular respiration. All right, well, we're going to stop there. That's about halfway through the first section. If you have any questions, watch this again and watch the videos. Until next time, I'm Mr. Hescox. Have a good day.